video, I'm just going to do one example where I verify that a triangle is a right triangle. In the problem, they're going to give you three points, and those 3 points correspond to the vertexes of the triangle, and our job is to verify whether or not this is a right triangle. Now, the easiest way to do that, since they've given us the vertexes, would be to implement distance formula, so you can find the length of the sides and then apply the Pythagorean theorem, and if you get a true statement, it can be verified then with that Pythagorean theorem that yes, it would be a right triangle. If the Pythagorean theorem would not hold, then it would not be a right triangle. Now, to start with, so that you would know which ones are the legs and which one is supposed to be the hypotenuse, I might do a really rough sketch, all right, of those. If you had graph paper, that would be good. I don't have any graph paper, so we're just going to do a really rough sketch here. All right, so looking at a rough sketch so that I can kind of get the idea of where my legs might be and where the hypotenuse might be. Okay, not drawn to scale here. If I plot the point negative 2, 1, negative 2, 1, so there's going to be my A. If I plot 2, 3, 1, 2, and then 3, okay, there's going to be B, and then C is going to be at 3, 1, right there, and so rough sketch there. Okay, so from sketching no more accurately than I have here, we kind of are seeing that it looks like the legs are going to be AB there and BC, and then the hypotenuse is going to be AC. Okay, so you might want to do that first just so you kind of get a hang of where this is going to go, because ultimately we're going to use that Pythagorean theorem and we're going to need to know which ones are the legs and which ones are the sides. Alright, so the first thing you're going to need to do is run distance formula on each one of those. So I would want to run the distance formula, say, of A to B. So a little geometry notation here, distance from A to B. Alright, that would be quick Pythagorean theorem. I'm not going to work out, or sorry, that would be distance formula. I'm not going to work the whole entire thing out because that's arithmetic. Okay, but basically it'd be 2 minus a negative 2 quantity squared plus 3 minus 1 quantity squared, and then the square root of all that. Okay, you can pause the video, do the arithmetic if you need to. That's going to come out to be a 2 square root of 5. Then we're going to do the distance then from B to C. And again, distance formula. So distance formula on that's going to be a 3 minus 2 quantity squared plus a 1 minus 3 quantity squared, and then again square root of that. And simplifying that out, you're going to get a square root of 5. And then again, for the last one, doing that hypotenuse, we would need to calculate the distance from A to C, and that's going to be a 3 minus a negative 2 quantity squared plus a 1 minus 1 quantity squared, and then the square root of all of that, and that simplifies down to a 5. If you need to practice the distance formula there, then go ahead, pause the video, see if you can get those 3 answers for those 3 lengths of those sides. Okay, but those have to be calculated first, and then if I want to test this with the Pythagorean theorem. Okay, so let's do that in a different color. I'm going to test here. Alright, so I'm questioning, is the distance from A to B squared, one leg, plus the distance from B to C squared, does that equal, question mark, the distance from A to C squared? Okay, so A squared plus B squared equals C squared. So I'm putting in and testing, and I'm testing because I've got, does it equal, question mark, does it equal that? Alright, so my distance from A to B was 2 square root of 5 squared, plus distance from B to C was square root of 5 squared, and again, still, because at this point I don't know, is it, question mark, equal to 5 squared? Okay, so let's do a little bit of math here. Let's see, squaring this, if I square 2, I'm going to get 4. If I take the square root of 5 and square it, I'm going to get 5, so 5 times 4 is going to give me a 20 right there. Square root of 5 squared is going to give me a 5 here. Alright, and then 5 squared on that side is going to give me 25. 20 plus 5. At this point, I can see that, yes, it does verify and prove that it is a right triangle, because my Pythagorean theorem here held. If I would have worked this out and this would not have been a true statement, then I could have verified that the triangle is not a right triangle. All right, now when you get all done with that, it might be nice, you've showed your work, you've showed how you've calculated the distance, and then you've verified there with that Pythagorean theorem, so you could draw a nice little therefore conclusion. Therefore, triangle ABC is a right triangle. Kind of makes it look a little bit more along the lines of a proof there. You've got a rough sketch, you've showed your calculations for your distance, and then you've done that Pythagorean theorem to verify it. So just one example there of verifying that a triangle is a right triangle when you are giving the 3 vertexes of that triangle. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.